Alright, this is Mr. Gillum, and today we're going to start working on some trapezoids and looking into those. Now, we've talked about quadrilaterals that are parallelograms. A trapezoid is a type of quadrilateral that is not a parallelogram. It only has one pair of parallel sides. Alright, there's some important vocabulary to keep in mind. The bases are the parallel sides. So as you can see in the diagram here, each of these is called a base, the sides that are parallel. Okay, the legs are the sides that are not parallel, of course. So the bases are the ones that are parallel, the legs are the ones that are not parallel. Specifically today we're going to be looking at some types of trapezoids that we call them isosceles trapezoids, and it should be easy to remember. An isosceles trapezoid, similarly to an isosceles triangle, or isosceles triangle has two sides that are congruent. An isosceles trapezoid has the same thing. Its legs are actually congruent in length. If the trapezoid is isosceles, then each pair of its base angles are congruent. So that's going to be important here in a second as well. As you look at the diagram here, this is an example of an isosceles trapezoid, and I know it's an isosceles trapezoid because of these markings right here. The legs are congruent. So if the legs are congruent, we have an isosceles trapezoid. Similarly to our isosceles triangle theorems, if it's isosceles trapezoid, these base angles are congruent. But this time we have two pairs of congruent base angles, as you can see. All right, so that should be relatable to your triangles. We also have a theorem that says if you have one pair of congruent base angles, then it's isosceles trapezoid. So just knowing that angle L and angle M are congruent, we know that the side lengths must be congruent, and we also know that the other angles would be congruent as well, angle K and angle P. We know this because, remember, if it's a trapezoid, then we have this pair of parallel lines here, and these are consecutive interior angles. These two guys, angle P and angle M, are consecutive interior, so are angle L and angle K, so they should add up to 180 degrees. If angle L adds up with K is 180, and angle M adds up with P, which is 180, and they're the same angle, obviously, then angle K and angle P would have to be the same angle as well. So one nice thing about isosceles trapezoids is that if you know that the two base angles are congruent, it doesn't matter which ones, then you know the other two base angles are congruent, as well as the side lengths of the legs are congruent as well. So it's good to know. Another thing that's special about trapezoids, isosceles trapezoids, is it shares a property of rectangles. With a rectangle, if the diagonals are congruent, that's the same as a trapezoid that is an isosceles trapezoid. So this is only if it's isosceles, though. Okay, the diagonals are congruent. It tells me that QS is congruent to RT. Okay. The converse is true the same way. If we're looking at a trapezoid and we notice that the diagonals are congruent, then we know for sure that it is an isosceles trapezoid. Okay, so they kind of snuck that converse in there when you weren't looking. Okay. If you see the diagonals are congruent, it's an isosceles trapezoid. It's an isosceles trapezoid if and only if the diagonals are congruent. So all isosceles trapezoids have congruent diagonals. All right, so let's take a look here, just this little diagram. I've got an example. It says the speaker shown as an isosceles trapezoid. Okay, so before I write anything else down, it tells me it's an isosceles triangle or trapezoid. So I'm going to say, okay, those lengths are congruent. It tells me that means that these guys must be parallel, and this whole angle is congruent to this whole angle. The whole angle F is congruent to the whole angle G, and it also tells me that these diagonals are congruent. Since they're intersecting one another, it's going to be hard to draw that on there, but the diagonals are also congruent. All right. So in the first case, it says just find the measure of angle FGH. So I'm looking at FGH. Oh, I guess I should label all my important information. FJH is 85 degrees. FJH is 85. Okay, FK is 8. And JG is 19. JG, the whole thing is 19. 19. Okay. Now if I want to find measure of angle FGH, I need to use the only information that I have about angles, which is FJH is 85. Okay, now in this isosceles trapezoid, that tells me that angle GHJ is also 85 degrees. And if you extend these lines, sometimes it helps to make a visual here. To make some line extensions here. These are consecutive interior angles. FGH and JHG are consecutive interior angles. So I know that 85 plus X should equal 180. X equals 95 degrees. Okay, these are consecutive interior angles, so they must add up to 180. Therefore, I know that FGH is 95 degrees. Okay, so I'm going to say 95 degrees. If I want to find the measure of KH, that would be from the center to this vertex. One property of isosceles trapezoids is that their diagonals are congruent. So if I know this whole diagonal right here, JG, is 19, and I know this little part of FK is 8, that leaves 11 inches for KH to be. So I know that the diagonals are equal. So if I call this little segment X, I know that 8 plus the X should equal a total of 19 because the diagonals are congruent. X must equal 11. Okay, pretty straightforward. We do need a label on this one, 11 inches. Okay, X is not part of an expression. X is literally the side length, so 11 inches. So a lot of similarities to isosceles triangles. Notice that some people were not doing these problems, but they're a big part of this chapter. So let's go ahead and take a look at these. And it says the quadrilateral ABCD is vertices of AB, C, and D. I've already plotted them here, and I made this trapezoid. It says show it's a trapezoid and determine whether it is an isosceles trapezoid. So for it to be a trapezoid, just a trapezoid, we need one set of parallel sides. So either AD and BC need to be parallel, or DC and AB need to be parallel. Now just eyeballing this figure, I'm going to go ahead and check to see if AD and BC are parallel first. And to do that, I'm going to use the slope. Use slope to see if sides are parallel. Okay, so I'm going to just go ahead and count rise over run. So I see up 2 over 1, up 2 over 1. In this case, it's going downhill, so I know it's rise over run. The slope of AD is negative 2 over 1, or negative 2. And I'm going to count the same way, rise over run, rise 2, run negative 1. So the slope of BC is negative 2 over 1. I guess it would really be 2 over negative 1, but same thing, or negative 2, same thing. Down to right 1. So I know that there's one set of parallel sides, and that's all it takes to be a trapezoid. So I know right away this is a trapezoid. So yes, comma trapezoid. I know that those two slopes are the same, therefore they must be parallel. Now I have a couple of options to determine whether or not it's an isosceles trapezoid. What I can do is I can see if the legs are the same length. I could also decide, well, are the diagonals the same length? Okay, those are going to be my two options. So I can use the distance formula or the Pythagorean theorem, whatever you'd like to use. I'm going to go ahead and just show that the legs are congruent because I think it's going to be easy just to draw in a right triangle here and a right triangle here, and I can quickly solve. Like I said, I could also do the diagonals, and if they were congruent, that would make it isosceles. So let's just take a look here. This is a distance of 1, 2, 3, 4, 5, a distance of 5. Therefore, 1 squared plus 5 squared should equal AB squared. And so 1 plus 25 equals AB squared. So AB must equal the square root of 26. So this guy is the square root of 26. And when I check for DC, I can tell already this isn't going to work out real well. 1, 2, 3, 4. 1, 2, 3. Oh, we have a 3, 4, 5 right triangle. So it's close to isosceles. The square root of 26 would be a little more than 5. This guy is exactly 5 though, so unfortunately, not isosceles. Okay, so number 2, we are check to see if diagonals or legs are congruent. All right, we're almost done. I just want to tell you a little bit about the mid-segment, and this is also got some similarities of the triangles that we've done. The mid-segment is exactly in between bisecting each of the legs, and so is the exact same distance between each of the bases. Okay, the same exact distance between each of the bases. It's also parallel to each of the bases. Okay, we call that a mid-segment. It's easy to remember because it almost sounds like middle. This is the important part though. Its measure is 1/2 the sum of the length of the bases. So if I call this x and this y, this would be half of x plus y. All right. If you add the bases together, those distances, half of that is the mid-segment. So with these trapezoids, and it doesn't have to be an isosceles trapezoid, it just has to be halfway in between each base, and it has a property where if you add each base together and divide it by 2, that is the length of the mid-segment itself. Okay, and this is just a fancy way to say all that here, just as example. So using that information, let's just do one more example here. And it says, in the figure, LH is the midsegment of trapezoid FGK. So it tells me that it's parallel to both of the bases. It tells me that each of these is separated into 2 equal parts. And it also tells me the big one is that if I add the distance, the length of each of these bases, x plus 18.2, half of that is equal to 15. Okay, so you can set up your equation one of 2 ways. You could say 1/2 times x plus 18.2 equals 15, or you could say x plus 18.2 all over 2 equals 15. So either way is fine. You can distribute 1/2 x plus 9.1 equals 15, or you can just get rid of all your fractions at once by multiplying both sides by 2. In the end, we're going to get the same answer. When I solve, my distance for x is going to be 11.8, and it doesn't look like there's any measurements units to measure, so 11.8 is what I'm going to say. Okay, and that's it just says what's the value of x. That would be the value of x. So I've answered the question. Oops, 9.1 half x equals 5.9. Multiply both sides by 2. X equals 11.8. So either way you do it, you get 11.8. And I think that's it for today. So we learned about trapezoids, isosceles trapezoids, and mid-segments of trapezoids.